Welcome to the Digital Amateur Television Experimenters Night. This is VK7OTC, the club station of the Radio and Electronics Association of Southern Tasmania. Amateur radio is a worldwide hobby that has many different aspects. Digital television is just one of the many modes and areas that are covered. Maybe you're interested in becoming involved in the DATV Experimenters Nights. You realise that you do not have to be a radio amateur or need any ATV equipment to participate anywhere in the world. Also participate in the night by coming up to the Queen's Domain clubrooms. Yes, right on top of the Queen's Domain in the heritage-listed Coast Wireless Station. You never know, we might get you in front of the camera or behind doing one of the many roles during the night. We get underway with our program on a Wednesday night from 7:30pm local time. We'll see you soon. This is VK7OTC.
Have you just know?
Alright, this is VK7OTC, the club station of the Radio and Electronics Association of Southern Tasmania, with our DATV Experimenters Nights, and I have a couple of regulars in the studio, Rex VK7MO and Hayden VK7HH. Hello Rex, hello Hayden.
Hello. Thank you.
And we have some very interesting boxes in front of us, which I will hand to Rex to describe what they are.
Right. Hayden and I have been talking about how we find ducts over several weeks, and we find them with radiosondes. And radiosondes are something that takes me back to almost to my youth. And given that Justin has been talking about ionosondes and radiosondes in the broadcast, I thought I should correct some misunderstandings.
Yes. Can I just say I've been using ionosondes where I should be using radiosondes?
That's right. Now,
but what's the difference?
Okay, an ionosonde. This is a radiosonde.
No. Sorry, I'm just getting it up on the screen, Rex. So
okay. Do you want to get an ionosonde up first?
Yep, I can do that. Let's just get there. Keep talking.
Okay. The purpose of an ionosonde is to actually transmit radio signals to the ionosphere and see how they reflect. And this picture you see here is of an ionosonde. It's typically something like about 500 watts. It's pulsed, so it acts like a radar.
Yep.
So it sends a pulse vertically up to the ionosphere, and it bounces back, and then they sweep it in frequency. And so the bottom scale is frequency, and it's probably going from about 3 megs to 20 megahertz.
Yep.
And in this case, you can see that at the bottom there's no reflections. That's low frequencies. Then you start to get reflections, and this is probably the E layer.
Yep.
At about maybe 100 kilometres.
Yep.
and then you're also getting some reflections from the F layer. No, actually, that one looks like a double reflection from the E layer.
Okay.
And then further up, at
bit.
about 500 kilometres, there's some F layer reflections.
Okay.
And the ionospheric prediction service have ionosondes, probably 10 around Australia, including a couple in Antarctica.
Yep. Okay.
One down at the Lee.
Yep.
And they produce this data and then produce predictions so that HF operators can work out the best frequency to operate. Now, as I explained, the E layer is sort of 100 kilometres and the F layer anything up to about 500 kilometres. So this is quite different to a radiosonde which we use to work out where the ducts are.
And these are done very. They're done all the time. Like, what is it? I think every 20 minutes. Or
no, usually only for 10 minutes. They sweep over about a 10-minute period each hour.
10 minutes each hour. Right.
Yeah, and that means all the ham bands get a burst.
Yeah. If you're looking on the screen, you see it go past.
With the ionosonde, particularly if you live where I am, with the ionosonde down at the Lee.
Cool.
So, but in terms of finding duct, these are useful for HF. Occasionally the E layer gets so intense that you get sporadic E, and you can use that up to 2 metres.
Yep.
But in terms of ducting, we're talking about something that works generally from 2 metres upwards.
And a different mechanism.
And a different mechanism. Instead of talking about 100 kilometres, we're talking about 1 kilometre, much lower down.
Okay.
Now,
cool.
The way radiosondes work, and we'll just go to the next
a radiosonde.
A radiosonde.
There we go.
They are launched as a package under a balloon.
Down here.
That's the package, and then halfway up is a little parachute.
That one.
Which opens so that when the balloon bursts, it at least psychologically makes people think it wouldn't have banged them on the head too hard. If it had have hit them. These are launched by the Bureau of Meteorology at probably 25-30 places around Australia and Antarctica, including out here at Hobart Airport.
Yep.
Twice a day at Hobart. There's about 5 stations that do twice a day. Most of them only do once a day.
Is that to do with the fact that it's associated with an airport? Is that, or is?
I think it's to do with labour costs.
Right.
You can have more staff near in the capital city without paying all the remote area costs. That.
Whereas they probably only do it once at Giles Weather Station.
Well, in fact, what they're doing nowadays, they're automating them, and they can actually set them up, maybe 30 of them, and they automatically blow up the balloon with hydrogen, and they can press a button and launch them so that the forecaster can even make a decision, one of these might cost $100 to launch.
Yep.
And he can make a decision, is it really going to help the forecast today?
Okay.
And they don't send them off.
Yeah,
not appreciating that they're important for our VHF analysis.
Do they ever retrieve?
No, they used to. And back in about... what I actually found is we used to have a sign on here, send these things back and you'll get, if you deliver them to a post office, you'll get 5 shillings. You wouldn't know what that was, but...
a small amount. Yes.
Well, it was a lot in 1950 or so.
Yes.
the problem was people were sending these back, and bear in mind they had a B battery in them. I'll explain that after a few months out in the weather, corroded and got over everything. People were sending them back to the post office, all with acid and corroded. And even if we got them back, 90% of them weren't reliable.
Yeah.
And then you spend another $100 sending something up that fails. So there was actually some words here that say something like, while this return of this instrument is not required, it is uneconomic to repair and recalibrate it for further use. Those words were written by me in about 1959.
I love it. What about the next sentence?
Please dispose or destroy as may be convenient. I wrote that too.
Yep.
Okay, now that's in sort of 1960s.
Hang on.
The technology that was available required the use of these things called vacuum tubes.
What we're going to do is, there we go, Rex. I can zoom in on this.
Okay. So we can.
Yeah, it's just there.
Oh, okay.
So come over to me and down a bit.
Okay, so in here we have two vacuum tubes. One is an audio oscillator, which is an RC oscillator, and the amount of resistance controls the speed of the oscillator.
Okay.
And we have some resistors, one of which is broken, but this was a thermistor, and so that the temperature changed the resistance of this device, and therefore the frequency of the audio oscillator.
Yep.
The other was a humidity element, which was a lithium chloride slide that fitted in there, and it changed the resistance and therefore the frequency.
Okay.
But we had two lots of data and only one signal. So to transmit two signals on one data, we had a pressure device, which if we look through here, you probably can't see it, but there's a little analog capsule, and as the balloon rises, it takes this pointer and moves it across a printed circuit and switches between temperature and humidity as it rises up in the atmosphere. There's also a reference resistor to calibrate it, just an ordinary carbon reference resistor. So this was the technology of the day.
So, okay, when you say the day, what sort of year are we talking?
Up to the mid 60s.
Okay.
And I guess if we, just to finish that off, go to this slide.
Now you're challenging me.
Now, this is back in the year 2000. The Bureau of Meteorology wrote a history of the Bureau of Meteorology, and in the history it says, I also remember Rex Moncur, who was the Radiosonde king in the early days.
Before he rose to his now exalted position of Director of the Antarctic Division.
Right, and now he's VK7MO. So,
I love it.
So these are the devices, except a more modern version. Now this is a version that came out when they went to solid state, which meant you could have a much lighter battery.
Yes.
Don't dong people on the head so heavy.
And from a size perspective, about a fifth the size.
Well, the volume a lot less. They're even smaller now.
Yeah.
So we now know how we measure the temperature, humidity and pressure, which is the data that we need to plot the intensity of ducts at VHF. So we will go to the next slide, and this is about where Hayden comes in.
Cool. Okay.
Yeah, so with that all in mind, we saw on Hepburn which uses radio.
Apologies for that.
To predict what was going to happen to ZL after we had our first opening with the really intense, strong stuff on 1296. We had this really weak patch. The green, the green in there.
There it is.
We
got there eventually.
The green in there is moderate.
Okay.
Enhancement.
Yep.
The purple is marginal, and I think the blue is mild.
All right. Okay.
So the green, we're talking about the darker shade of green.
So there is a complete green, apart from that little bit there, but there is a complete green path to...
Yeah, so we were right on the edge as well, and we wanted to see what the differences were in signal strength between that path there and the day that we had the really strong stuff across parts of the path. Okay. So you can see that across that path it's pretty much consistent all the way along.
How did you do that?
Well, we didn't have as much success finding as many keen Kiwis. They were all working that day.
It just happened to be a public holiday for Regatta Day.
It was Regatta Day our end, but not at the other end. So what we did was we listened to the ZL1SIX beacon, which transmits every 6 minutes.
Yeah, about 20%.
Yeah,
like that.
Every 6 minutes. So on that chart is the signal to noise reports, and you can see...
It's the difference between you and Rex.
Yeah, so you can see Rex... these would be at the same times, were they? Did you
yes,
line up the
no, I didn't line up the times. I picked the best 10 for both of us.
Yeah, okay.
Because you only gave me the best 10.
Yeah, so the best signal that I or the best signals that I received was about 3 a.m. our time.
Okay.
So it was pretty much all through the night and was open 24 hours, I think. Wow. So obviously Rex only got to -16, and I was regularly seeing more than -16, which was interesting. So you can see the differences in dB between the two stations.
And we both have similar antennas.
Similar antennas.
I've got 10 elements. What have you got?
I've got 8 elements.
Yeah. So if anything, you might be.
I've got no preamp, but I've probably got less noise.
Absolutely. Yeah. Yes, I've been across Hobart, which is a noise factory.
So that's from Mount Lloyd. On the right.
Cool.
Then Nick ZL1IU come home from work, and I worked him no problems, and that was the signal report. And we kept hearing the beacon across. Yeah, I think it was well into the morning. I think it was about 1 a.m. I think the next day when it faded out. So that sort of proved that even though we didn't really have much opportunity to try anything higher, so 432 or 1296, because there was no one at the other end. But it does prove that at least on 2 meters, signals were around about the same, if not as strong as.
So ZL1SIX is only a 2 meter beacon?
So ZL1SIX is only a 2 meter beacon, and it's very close to where Nick is. It's a little bit higher. It runs about, I think it's 40 or 50 watts. It was running 10 watts, but it's just been increased to 50. And it runs a couple of 3-element Yagis stacked, I think 4 of them, pointing towards VK, because then it covers from VK4 to VK7.
Yeah. Cool.
So it's very handy to listen to. And then the next slide is the Radiosonde data at Auckland.
Very good.
And Rex can show there that the line is the gradient, refractive gradient required for a duct to form, and it is just above that.
Only just, though.
Yes.
Or just below that.
Oh, truly. Compared to?
Yes.
Hobart, which was off the scale.
So I had to rescale.
and Auckland's, what was Auckland's height again? That was
just on 1,000.
Yeah, so they were fairly similar heights. So the other thing to note about, I suppose, Hobart's is that the site. So my remote site's about 930 metres. So it's just below where that duct is. Whereas Rex is a lot lower. You're about 500 metres.
300.
500 metres lower than that. Lower than my site, sorry.
Yeah, more than that.
Yeah.
650 metres below your site. Yeah.
So maybe that's got something to do with
you
how
were
well I
almost
got
in the duct.
Possibly at times.
Yeah,
maybe.
because the duct's being measured at Hobart and his station's
Further west.
west,
okay.
it's quite possible you're in the duct, and that explains.
The increased signal to noise ratio.
Yeah.
Wow. Cool.
Was that done at 11 p.m. the night before, or was that done the day? Do you remember?
Forgotten.
Can't remember. Yeah.
Okay.
I think it was during the day.
Yeah. Okay.
During the day. Yeah.
But there the whole day. And how did Hepburn? What did Hepburn do? Because Hepburn has, I think, there's 3 snapshots during the day. During a day, did that green stay there, or
Forgotten now.
For the most part, it did. So what happened was there was a high that moved under Tasmania,
okay?
and then that moved up into the Tasman, and then it started to. I think there was a low that was pushing down, and that's where the edge was just at the bottom of Tasmania, so it kept pushing that.
So it was between the high and the low. Was
and it kept pushing the green further and further south.
Okay. Cool.
So it if you looked at the Hepburn charts, it come in before it was expected, and it left well after it had said that it was.
So 24 hours, basically.
Yeah,
you were receiving the beacon for 24
probably
hours.
longer than 24 hours, probably a tad longer.
Wow. Cool.
So, but it does prove at least the theory that you don't need super strong pink, red across the path. Yeah.
Well, here's the most intense duct I've ever seen in Hobart, and Hepburn was effectively saying it's mild or.
Well, you were almost it was almost in the black right on the edge of Hobart.
That's right.
And of course, you've got to also rely that it's going to be like that or similar to that across the entire 2,500 kilometre path,
which it clearly wasn't, because it was only just over the 157 at Auckland.
Yeah.
And of course, there's no monitoring. There's no radiosondes in the middle of the Tasman to monitor.
Well, that is fantastic, guys. Fantastic. Is there any sort of prediction for the coming days or weeks, or well, as far as Hepburn predicts?
I think the weekend there's a little bit in Bass Strait, but nothing in the Tasman Sea.
Yeah. Okay. So how have you got a feel for how often there is that sort of path across the Tasman during a summer? Are we talking 2 or 3 times a summer, or?
I suspect we'll find that it's more than that now.
Yeah, okay.
I think particularly now we've got a whisper beacon continuously transmitting
towards us
that we can monitor.
Yep.
And that whisper beacon has also been heard in VK5.
Whoa, okay.
Which is over 3,000 kilometres.
Ooh, yeah, okay.
Yeah.
So that means
that could be a bit of spread key involved.
It could be a little bit involved, but definitely there was a hand with Tropo in it.
Right.
Yeah.
But there is the potential that if things are lined up where there was maybe sporadic or even Tropo in the Tasman at the same time as in the Bight, it could be you could get a path to VK6, possibly.
Wow.
And that's a long path.
Well, truly.
Yeah.
But you'd have to have a lot of things line up.
Yeah.
Okay.
But I think whisper beacons are going to be a boon as more, particularly GPS locked whisper beacons.
Tell me about it.
And you can sit there and you can watch it. So every time, and you can then compare, because it's every 6 minutes. You can see the differences in signal to noise, and as it starts to get stronger.
Yep.
Yeah,
that's
it's really only about once every 20 minutes that he transmits.
No, it's more. It's definitely more often.
Is it?
He's on a very high duty side.
Okay.
I think it's 30%.
I'm thinking of yours.
Yeah, mine's a lot lower.
Yeah.
But I'm also thinking in reverse, because we now have at Snug a 62 and 70 digital mode. It's not whisper. It isn't whisper. It's WSJT, JT65 and JT4. But we've got, we're transmitting that from down there. And it's not a directional antenna, which is working against us. It's an omnidirectional antennas. But yeah, okay.
I mean, I think a very interesting thing would be to run a whisper beacon in Tassie pointed with a reasonable antenna pointed at New Zealand.
Well, that's essentially what I've been doing, and I do get decoded by ZLs on mine.
Yeah.
Okay.
Is that from Lloyd?
Yeah.
Okay.
And that's
Sorry, I should have.
yeah, and that's what mine's been doing the majority of the time, and then I move it to VK5 when it looks good there. And
Yeah.
Fantastic. Well, that's fascinating. Absolutely fascinating, and thank you, Rex, for...
Just going back to what you said about how many times in the Tasman it happens, usually you can tell that if it starts to move through the bight and it looks strong in the bight, then it might move into the Tasman eventually.
Yeah.
Whether it extends down to Tasmania is a different thing. It usually goes up towards New South Wales, Queensland.
Okay.
But yeah, it does happen more often than what we realise.
Okay. Cool. Fantastic. Thank you, and thank you, Rex, for bringing in a fascinating piece of history from the Radiosonde King.
Yes.
So, what I might do is call on Ron, actually. If Ron can bring his latest project into the studio, that would be fantastic. We'll just reset a few cameras here. Zoom out. Whoa, that's not good. Zoom out. That's a bit better. Fantastic. Okay. And go. Come in, Ron.
I wonder if we're going to be able to see this with the plane.
Well, we'll be able to do that because we'll do it with that camera, and I'll zoom in on this and I'll zoom in on that a little bit later. So, so I would like to. Actually, hang on. So you can see what we're actually looking at here, and I'll just. There we go. That's a bit better. That's a bit better. And I'll welcome Ron Cullen, who is a semi-regular contributor to the ATV nights in the studio. He's always out there, beavering away with his radio-controlled bits and pieces. Now he has a really, really impressive setup that is sitting in front of us. So what I'll do is get you to describe what we're actually looking at, and then we'll zoom in with the camera and take a bit of a closer look and all that sort of stuff.
Right.
Welcome, Ron.
Thank you, Justin. Yeah, so this little project is a antenna tracker for the model aircraft. So it's all for the video signal, because when you start to get a little bit too far away, or you've got trees or other stuff blocking the signal, your video picture deteriorates in your goggles. So I've made up this little antenna tracker with a high gain patch antenna and a servo, and what it does is it tracks the plane as it's flying around and keeps the high gain patch antenna focused on the plane, with the intention of getting a better video signal. Now, this hasn't been operationally tested yet, but got the fundamental parts of it working now, so the next time I go out flying, I'll give it a go.
What we might do is... there we go. I love it. So what we're looking at is we'll just move that to the side a bit. So just point out and describe what we're actually looking at here, Ron.
I also wonder whether it might work under there. It's a bit too big.
A bit too big.
Right. Okay.
we have trouble zooming out on that one.
So what we've got here is a Lazy Susan bearing, or actually the bottom half of the Lazy Susan, and you can see the red board is attached to the top half. If I just take the cover off.
This is where the smarts are.
Yes. Right.
But just describe what we're actually looking at. That's probably the easiest thing. Now, if I hold that for you,
right. So you have the laptop, which is sitting on the field with a telemetry receiver connected to it, and the model aeroplane's transmitting telemetry from the onboard flight computer. It has a GPS attached to it, so it's sending across GPS coordinates through the telemetry, which gets received by the laptop, and then the laptop then does all the calculations, because it knows where it is and it knows where the plane is, so it does all the calculations for the trigonometry to work out its height and its distance and its bearing and all that sort of stuff.
Phenomenal.
And then that information normally is plugged in via a USB cable into this little board just here. That's a serial servo multiplexer controller type of board. And so that you can see the little USB connector just there, and then the USB signal comes in there. That little chip on there decodes all the information to steer the servo, just located here. But having a cable connected to a rotating thing is not the best idea. So I saw on a blog that somebody had done a similar thing and attached a Bluetooth device. So I've paired this Bluetooth module, little Arduino type of Bluetooth module, to the laptop, and then instead of using the USB cable, I've just connected the COM port in the software to go via Bluetooth. So we receive all the coordinates and information through the Bluetooth. It's fed serially into this servo controller card, which then moves the servo around to point towards where the aircraft is.
Phenomenal.
Now, it's all being run from the LiPo battery here, just a 3-cell LiPo battery, so 11 volts. 11 or 12 volts. All of this stuff basically runs on 5 volts. So over on this side here, I've just got a 12 volt to 5 volt buck
Converter.
Yep. And then the output of that feeds the majority of it. But one of the pins on the Bluetooth runs at 3 volts. I think it's the receiver input.
Yep.
So rather than forcing 5 volts onto it, this little board down here is a logic level changer.
Yep.
So then it changes the 5 volt serial signal coming from the receive signal coming back from the serial servo controller, converts it from 5 volts down to 3 volts, so then it'll interface properly onto the Bluetooth.
Very nice.
Now, if we just pop the lid back on again.
Yep. I do like the lid too. This is a container. Plastic container that's had little notches cut out of it for the wiring. I love it.
And I was working on it, and I said to the missus, I need to cover all this stuff with something. So she grabbed this plastic container out of the plastic Tupperware container cupboard at home, and she said, you can have this one because I've lost the lid, so it doesn't matter.
Excellent.
And the good thing with it is because it's almost right angles, I've got these little wooden things which I've hot glued in there, which I can just put screws in, so to hold it down. I've got the screws removed at the moment. You can see the hole there.
I love it.
Now, the aircraft video signals, the channel that I'm on is 42, and it gets received by the patch antenna or the circular polarized omnidirectional antenna. Goes into this diversity receiver. So when the plane's a long way away, you'd imagine that the signal will be strongest in the patch antenna, so it'll be coming through that side of it. Yep. When the aeroplane's close, it'll be coming through the omnidirectional one, or if it's outside of the beam of the patch one. So the video output of the receiver then comes down and goes into a little tiny 25 milliwatt transmitter I've got sitting on the side. Now that's tuned to a different frequency. So you tune your goggles into this one, so it's all wireless. Everything's wireless. You don't have to have a cable coming from here going to your goggles or anything like that. So we're receiving it on channel 42 and going out on channel 48. And Martin was having a look at it. He asked a good question. He said, what's going to stop the harmonics or the frequency or intercarrier frequencies affecting both of them? Intermodulation.
Yes.
And I did think of that, and I thought, well, what I might do is, by trial and error, I'll just set the both of them up, and I'll transmit on one and watch the blank screen of the other one and see if I get any interference. But then I thought, but hang on, somebody else must have done this before. So I Googled it, and I found a chart, or actually an interactive website. You choose your channel, and it tells you all the other ones which won't be affected.
There you go.
Yeah, or ones which will be affected.
So someone's done all those intermod calculations.
They have, yeah. So all I did was I've chosen 2 frequencies which won't interfere with each other.
Fantastic.
With these 2.
Cool.
Right. So, how can we...
So what are you going to demonstrate for us? That's probably the easiest thing.
So the software that I use for tracking the aircraft and on the laptop with the telemetry and everything is on the laptop here, and you can set it in a simulation mode where we can actually fly the aircraft around in simulation mode, and it generates all the coordinate information as if it was doing it for real. So that way we can do a live demonstration of how this works from a simulated signal.
Cool.
So how would we set that?
Well, probably bring the simulation up on the screen.
Yeah.
And then we'll show that. And then. Okay.
Just go. Yep.
Cool. So the tracker's just done a little calibration. Is that what
it's got a signal sent to it, so the servo's just jittered.
Yeah. Okay.
So it's
right. So
select this plane and if I turn that around.
Yeah. I'll zoom in on that.
Stabilize.
Turn that
Airspeed 1 calibrated.
So what are we looking at here? This is the simulation software.
Yes, and we'll have a look at that in a minute.
In a minute.
Yeah. And if I turn it around, so it's
HRS.
and then we'll move it across because it's
Yeah.
Okay. Right. So the aeroplane is, you can see the red aeroplane there in the middle. We can't get maybe a focus or something. Right.
There we go.
So what we're going to do is make a pretend flight plan. So the aircraft is there, and I'll just zoom in a bit there. Right, so that's actually at home. That was the last place where I had a GPS coordinate.
Okay. Yeah.
So the first waypoint I'll create will be a takeoff waypoint because you need to take off. So I've already got one there, so I'll just remove that one. So set that to take off, and then what we'll do is we'll fly over to the right, and then we'll go right across the front of us over to the left, and then we'll come back to where we started from, and we'll just do a unlimited loiter, which will just fly around us above us in a circuit of 100-metre radius.
Cool. Okay.
So you need to write that to the aircraft, upload it to the onboard flight computer, and then we need to arm the plane.
Armed.
And then set it to takeoff.
Auto. Heading to waypoint 1.
Right. So now there's the plane heading off. Now, I wonder if we can't get to this one.
No, we won't. We're
Heading to waypoint 2.
Oh, hang on, wrong way.
Oh, there we go.
There we go.
Wait for you to zoom out to get both of them on there. Yeah, this might show it. Oh, yeah. So
Heading
it's
to waypoint 3.
the plane is now about 90 degrees to our right, and the tracker's moved 90 degrees to the right. Now it's going right across the front of us and over to the left.
That's right.
Heading to waypoint 4.
Right, it's gone in behind us a bit, and there we go.
There we go.
Now we're doing a loiter, going in circles above the top of us. Now this is only a 180 degree servo, so it won't do it behind us. What happens is the plane flies around behind us, and when it starts to come into view on the other side, then it spins around and picks up its track again. So then now it's flying in front of us, and then over to the right, and then it goes behind us. And where it stops, and when it comes around to the other side, it'll then switch around and pick it up over to the other side. Now when I get a 360 degree servo, it'll do a similar thing, except it won't continually go around in circles. I reckon it'll go right to behind you when the plane goes past, then it'll come straight back around and point back to it the other way. Yeah.
It's probably set up to think that it is not wireless. So, because if you've got cords...
Yeah, well you can get like 720 degree servos, and they'll go around, but I don't think the software supports 720, it supports 360.
Okay.
So that's not going to be of any advantage.
We have exactly the same issue with rotators on towers. There's a 720 setting that you can set up, or a 360 or a 180, depending on what's there. So
well, this is in the software here. You've got your 180 or your 360, but not 720. Yeah,
that is fantastic, Ron. And so how? I'll ask the leading question. How long did it take you to get to this point?
Well, this one's my third attempt at it. The first couple I've sort of haven't been able to get the mechanics working in it. Okay. Because I originally started off with a servo and a few cogs, and I was trying to gear it. Yep. And the Lazy Susan, it's not made to find enough specifications. There's a little bit of play in it. Okay. And I found that when I was trying to align the cogs up, if I didn't get it perfect, then I'd start to bind and then start to strip, and it sort of gets jammed.
It's all downhill from there, really.
Yeah, the mechanical side was I just couldn't get it to work. And I hadn't even got to the electronic side at that point. Yep. And it was last weekend when I just thought I'd revisit it again, because I had a little bit of time up my sleeve, and I just thought of a different way of connecting the servo. So everything's lightweight. There's nothing here that's going to overstress the servo. Yep. So I decided on just finding the dead centre in the middle of the Lazy Susan, and then the top of the servo, the control horn on the servo. What I did was I hot glued that to the board, and then just inverted the servo and plugged it straight into it, and then attached it to the board that's on the top. Fantastic. And it just all worked perfectly. So it hasn't been any binding or anything like that. So it's
that moves really freely.
It seems a little bit jerky, but I think that's because of the sloppiness of the Lazy Susan bearing and everything. It's got a lot of play where it'll.
Fantastic, right?
Yeah.
Okay, and congratulations. So what's the intention from here? Like, you're going out to do a bit of a test?
Yes, yeah. So one of the places where I fly, I know when I get out to some certain points, the video signal deteriorates really badly.
Well, that's good. You know that happens.
I know where they are. Yeah. No, I've from previous recordings, I've got it on there as well. Okay. So I'll be able to fly the same path, go to the same position, and do a comparison to see what the video looks like. Fantastic. Hopefully it'll be a lot better.
Cool. Well, good luck.
Thank you.
I look forward to the next video, which of course the video will be perfect.
Yeah.
The whole flight.
yeah.
So no, good stuff. Very good.
Right.
Thank you, Ron.
Okay.
Thank you very much. Now, can you send Larry in for me?
Yep.
We've got a cast of thousands tonight. That's just phenomenal. So that was Ron with his update on his tracking using the Lazy Susan, and I think that will vastly improve the AV signal on his radio controlled aircraft. So there you go. So come in.
No, you go.
No, go ahead.
Well, we need another chair, don't we?
We need another chair.
Go.
And I need to, if we're going to another chair, I need to go to a slightly wider angle.
Put on an ugly filter on this here.
All right. So we've got Rex VK7MO back in the studio, and we've also got Larry VK7WLH, who is a regular contributor to our ATV nights. Welcome, Larry.
Nice to be here. Thank you for the invitation.
And what are you going to be talking to us about tonight?
The current adventures of Rex and Larry. in search of the perfect clock.
Time nuts. Yeah, okay.
Yeah, I used to think that would not apply to me, but no, it seems to be.
You've been comprehensively sucked in.
And 10 to the minus 6 is meaningful now. It used to be not anything. Okay, so through a combination of funny phone calls and lots of help from people, Rex and I are getting closer and closer to quite, I don't know if it's accurate or precise.
No, I don't know the answer.
We're getting pretty close to the right time.
But Monty criticised somebody for not talking about accuracy when they meant precision, so I presume he knew what he was talking about.
Just be very careful.
See, I originally thought accuracy was being right on it, and then precision was how many decimals you could describe it as.
Yes.
Apparently that's all wrong, but in that case I don't know what's right, so I'm just leaving that alone. Okay. I'm not sure how much of this will go underneath your...
No, that's all right. We can certainly do that. Close-up camera.
Well, not too close.
All right. What would you like to show first?
Okay. Well, now you got to go way back.
Hang on, we'll zoom out here.
Yeah. We are using two programs. One is NMEA Time 2.
Okay.
And that is a program which runs on a Windows PC and also receives a signal from a GPS receiver. The GPS receiver is outside of my shack, and it's connected with a USB cable into my PC.
Okay.
And it receives a signal from the GPS, and the software processes, well, many signals actually, and it will then discipline my PC clock to bring it on time.
Okay.
So it has essentially the same kind of NTP, network time protocol server kind of situation that many Windows machines use, except Windows 10. Windows 10 is essentially Windows 10 goes back and asks Microsoft in Seattle what time it is once a week, and once a week isn't good enough.
Correct.
Okay, so using Visual GPS and NMEA Time 2 in this particular instance, we are Visual GPS is the company, NMEA Time 2 is the program.
Yes.
We're able to get pretty tight. Okay. This gets to be a matter of definition now. Rex and I agree that we're typically within 0.07 seconds, which is 70 milliseconds.
Okay.
Pretty good.
Okay.
Yeah, after that's the calibration that we have to add.
I use that as well, but what do you consider to be how close are we generally to real time?
For our audience, this is a time nuts aside.
Anyhow, there's a program which requires some calibration, but you have to you've got to figure out how to calibrate. It's not very far off, but calibrating it brings it in quite closely.
Okay.
Move to the other part of the page there.
So over here?
Yeah, now that actually said something 1437 or something like that.
Correct.
And down below you can't see it, but the locked part, the part that says oct, is locked.
Yes.
It's normally green.
Yes, it does say.
It does say locked, and then it shows you how many milliseconds.
A time error of 3.366 milliseconds.
Yeah, well, that's a guess. We're not sure what that means, but it's not too far off, we don't think.
Okay. Cool.
I think we can say what it is.
Okay, go ahead.
Essentially what it does is it averages the time over a long period and then tells you what the difference is to the average.
Right.
Which essentially means it's checking the time again, it's producing the error against the same source. So it's not really against an independent source, that error.
Okay.
However, the primary signal is coming from a GPS satellite.
Yes.
Or GPS device. So you do have something you can refer to.
Okay.
And it's trying to get the PC clock as close as it can.
Yep.
But because a lot of variables in the system and delays and whatever latencies and things, it gets pretty darn close. I don't believe that it's 3 milliseconds, but I believe it's less than 70. So can I pass along your definition of our accuracy? It's 0.1 second plus or minus 0.1 second.
Yeah, okay, I understand that. So can I ask the obvious question here, which is, why are you doing this? What's the application where you need this sort of degree of accuracy or precision or both?
This is like Everest because it's there. No.
Right.
I'll try and answer that question.
Yeah, please.
When you're using QRA,
Yep.
it has a time offset around the moon delay, which is about 2.3 seconds.
Yep.
And that means if you're more than 1 second out one way for terrestrial,
Yep.
it won't decode.
Okay.
So you don't want to be more than 1 second out. There is an advantage, and of course you've got two people, so you want to be a lot better than
Between you.
between you.
Yep.
There is an advantage though if you're looking for a weak signal and it comes up with exactly the right DT to within 0.1 of a second.
Yep.
It tells you you're getting sync even though you haven't actually received a signal.
Okay.
And that, when you're waiting on a very weak signal, is a very encouraging sign. And so it is worth trying to be within 0.1 of a second.
Okay, cool.
I don't think we can get within 0.1 of a second yet, particularly when you take account of the errors at both ends. But that's why I believe there is an inherent, at least in my 9700, there's an inherent delay of about 0.07 of a second while it processes a signal.
Yeah, this will be the conversion latency.
And mostly in the USB
Sound card processing.
Processing.
Okay.
The interesting thing about it is if I go directly into my computer at audio, the delay is longer than if I go through the 9700 and its sound card. So it must have a much faster sound card, including its latency.
Yeah.
It would be nice to be a bit better.
Okay.
Bear in mind, WSJ Towney prints out QRA to 0.1 as a second increments.
Yep.
So there's not a lot of advantage being much better.
Yeah.
But it's worthwhile resolving to at least sort of 0.1 plus or minus 0.1 to give you some confidence that you're getting synced.
Great. Okay.
And as you can see, this is a work in progress.
Now,
using a program, different program than the one I mentioned earlier.
Yep.
This is used by the guy who builds all this stuff, and he uses this program to tell him, not discipline his clock, but tell him what his PC clock is different from a network time server. So this is simply an indicator.
Can I just indicate that it's a network time? It's a Stratum. It's a Stratum 1 network times.
Correct.
Which is the top of the line.
Yeah, and the Monash one, that one which has different URLs, is pretty good. So that is a picture taken. Now notice one thing. That 0.0034 is at the far edge of the green. Notice a couple of excursions there, both up and down.
Yes.
So you can, and that's what I think Rex is talking about, how we have to, this is fuzzy and down to a certain point you can't go any further.
Yep.
So, but these are no doubt valid numbers at the time.
Okay.
As far as we know.
The 0.034 is the instantaneous value.
Right.
But you can see there were little spikes that were probably much more than 0.034.
Yeah.
And I suspect that's to do with the internet. Every time you ping the server in Melbourne, you get a different answer.
No, well, you do, because that's to do with traffic at the time and all sorts of things.
Yeah.
So, okay.
And here's one I'm very proud of. Taken just a few minutes, well, not many seconds after that one. But if you notice the offset.
Oh, okay. Lots more zeros.
Yeah.
Very nice.
Now, what that means in the real world, I don't know. And I don't know if it's meaningful otherwise, but it says that my PC clock, by its calculation, was off by that much.
Don't you hate it when it rounds it up? Sorry.
So I leave it to Rex to define it, because this is just an interesting pursuit for me, and it is meaningful in terms of a lot of other things. But for Rex, it's really important in the field. It can be very useful to have good time in the field, right?
Absolutely. And I mean, in the field, you often don't have internet time.
Yeah. So I'm having a good time helping Rex, but really he's the one that is. Well, this is the name of an article which you can look up on Google. where on earth are the best 50 time servers? Now, this is 16 pages, I think. Anyhow, it's a lot.
It's actually written in Australia.
Yeah, Sydney.
Well, in Australia.
Yeah, and it's quite well done. And I don't know how current it is, but it's because there is no date on it. But in fact, it describes the various different kinds of time and what's going on and how the NTP servers operate and things. So if you really want a good background on it,
cool.
It's a nice. It's not just where are they and what they are. Mostly, it refers to what is it, ntppool.au or something.
Yeah.
And it refers to the NTP server pool, which a lot of people use because it's reliable, because there are a lot of them, and some of them are off. Some of them aren't on or turned off for maintenance or whatever.
And the advantage of using the pool is if there are some servers that are off, then the other servers take up that time. So you're not relying on a single source. That's the advantage with the pool. But you've got to be very careful with the pool because it may be a Stratum 1, 2 or 3 server. So and you don't necessarily know unless you know what those sources are.
And from our perspective, unless you know how far away the pool is in terms of its path, you might be worse off than using Monash, which seems to be more stable.
I don't know whether they still do, but UTAS used to have a NTP
we can
source.
use TAS, but it's worse than Monash because UTAS sends a signal to Melbourne and we get it back again, so it's twice the path.
It's the ARNet link. Sorry, I'll go into that
later. However, if you look up
if you could access the thing out at Cambridge directly, it would be
the
better.
NASA. Yeah.
You're hoping someone will see the video and help out.
Well, you could talk to them at on the Sunday when we go out to the Great Reba Museum for the WIA conference. Hint, hint.
So in fact, very good time is available. Certainly, time for most folks.
Yep.
And I think that it's a good basis for Rex to use, and that calibration business is calibrating the software that uses a GPS signal.
Yep.
So it is useful where Rex goes out in the middle of nowhere to have GPS time, and with proper calibration, it's pretty good.
Oh yes.
Yeah, so it's a lot of fun with this, and it is time nuts because it's one of those things like putting your thumb on a piece of mercury. It just goes all over.
Yeah, it's the 2 watch problem.
Yeah.
Which one's right? So Rex, are you intending to use, or this is one of the things in your toolkit when you go to Hawaii?
Yes.
Yeah. Okay.
Because the chances that I will have access to the internet reliably is complete.
Yeah. Although, if you're going up the rather high mountains in Hawaii where the radio astronomy observatories are, I'm sure that they have mazes.
Yeah. Bear in mind, I've got to be very mobile because I've got to go up and down chasing duck sites and things like that.
And in fact, that's a good point because if you went up to where those observatories are, I suspect you're going to be above the duct.
Yes, absolutely. That's right. That's why they put them there.
Yeah,
because
they're up above everything, all the crap.
Well, the duct has all this cloud in it. In fact, the guy who did most of the research, K86HME, reported that every time the cloud layer dropped below him such that the sun shone, the signal disappeared.
So, is that saying you can't get into the duct above the duct?
That's what it is. So,
ooh, okay. There you go.
We could try pointing down. And I'm always wondering what happens when 60 watts of 10 gigs hits a rather large radio telescope.
Well, hey, there you go. I love it. This is fantastic, guys.
Well, we're still in.
So our resident time nuts. Thank you very much.
We'll send it the next.
Can you send in Richard?
Richard, yes.
Which Richard?
Richard ZBX.
ZBX Richard. Right.
So that was Rex and Larry, our resident time nuts, talking about how they're trying to accurately get or make their PC clocks even more accurate. So I wish them every luck with that. Having done just recently, I have a new Thunderbolt, Trimble Thunderbolt that I'm trying to get some decent readings out of it. Come in, Richard and Rex.
You go.
You go in here.
Come in. Part of this.
Sit next to. Oh yeah, sorry. And in fact, you can say, because this is about the Summer VHF UHF Field Day.
Oh yes.
So Richard, quite rightly, and in fact, welcome Richard.
Thank you.
VK7ZBX.
Thank you.
And welcome back, Rex. Richard pointed out to me that the contest organiser is in Mike VK3AAV. Is that right?
I think that's him.
Sorry, I'm just trying to look for his name. Is the wonderful guy who does
he does the computing. I think
VK
Harrison's still the
CL. He's the interim contest manager
for the last 5 years.
So thank you, Roger, and thank you, Mike. Send out the email to with the contest details, which totally went past me because I just if I'm not on the ball,
spam folder, I think.
No, it was still there, but it was just there was an awful lot of other emails that just swamped it. So I dug it out, and I thought we'd just run through a little bit of a few learnings. I think because we're still doing learnings. Yes, I know. Tim and Ian. No, that's Dave mentioned. That's KK. So all the way up to 122 gigs. So it's basically he's filled in all bar 50. He didn't operate 50 megs because that's DC to Dave.
Yeah.
So but they come out with the results. Now the results are, I think, exemplary. They are. There's a fantastic little program that Mike, I think, has come up with, where he takes quite a number, and I'll just let you know because there's some percentages here.
She grabs all the Cabrillo files and
Correct. So no, that's something I just wanted to point out. But I think it's 40%. He ended up checking this year. 40% of logs to a pretty reasonable degree. Now, actually, just so that people are aware of what we okay, so it's up there. This is the provisional report, so that you get, which is all of the results for all the different sections. There's a little bit of analysis at the end, some comments and bits and pieces. And if you happen to be unfortunate enough to get something wrong, or where they have actually done a check of your log and found that you have done particularly bad things or whatever, or missed a grid square, or missed a name, or mistyped a grid square, and then relied on that grid square for every other contact that you had with the person.
never happened.
No, you get what they call a log check report, which is personalised for you. Now, I'm not going to go through everything here, but what I thought I would do is I was just going to go through my log check report, which just to show you the issues that can occur, one comment I just picked up on here in the log check report, a comment that he says the change in penalty for incorrectly worked locators, which are points calculated with correct locator and then reduced by 20, resulted in high loss of points in most cases, particularly for the long distance contacts. Do check your worked locator frequently with the other station to minimise losses. So it's worth actually rechecking the locator even if you've worked them before, because then you've got a chance of, if you get it wrong, Mike, APV. If you get it wrong, then at least you've got a chance to actually correct it. So when you put your log in,
rather than just blindly following along and making the same mistake twice.
Correct.
3 times or 4 times.
So in my case, I made. Now, fortunately, there are particular errors where it doesn't affect the number of contacts. So they don't actually remove the contact, but they reduce the number of points for the contact. So, okay. So I had 44 claimed QSOs, which was great. And after checking, it remained at 44, which is good. However, I claimed 10,475 points, and after checking, it went down to 9,973 points. So I had a 4.8% score reduction. And the reason for that is, and it was all about the 6 metre contacts in the case of me.
Been pointing the wrong way.
Yeah, right. That was the first problem. And of course, the 6 metre contacts were where we were making the big points.
Yep.
Because we had a great opening to VK4 and 5 and 2 and etc. etc. So what you actually get is, in the case of an incorrect worked locator, this was me getting their locator wrong.
Oh, yep.
So both of those, minus 259 points and minus 243 points.
Do you think it was that you got the locator wrong over the air, or you just wrote it down wrong?
Yes.
Both, I reckon. Because if you look at, they actually give you what you wrote down and what was right, and it's always like it's Q.
See, that's almost like hearing something wrong.
Oh, no,
between a C and a G.
QC61LG, which is actually QG62LG, and then QG61JT versus QG61JC. Then stations copying your call band exchange or locator incorrectly, which is correct. They said it was QF36EN, whereas I was actually operating QE36WX, so that's a bit weird. But anyway, and then this is a classic example of, I worked KAF, and
PW.
it was VK7PW, not TW. And then Alan, I got the he got the locator wrong. And this is the classic example of, I worked Vince, and he got my locator wrong and just assumed the next contact was the same, and exactly the same with Murray for the 4 contacts that I made with Murray. So he wrote it down as WE, not WX, and then relied on it for those 4 contacts. So the key message here is recheck. Even if you think you got it right, recheck the locator with each contact, so you've got a chance to then at least pick it up and correct it.
We were really lucky. We didn't lose any.
However, the only other thing I wanted to point out here was we had a really good roll up of VK7s. That's all the highlighted ones.
Well, the club came second.
Club came second. Absolutely love it. And here we go. The long distance verified contacts, 50 megs, so 6 meters. VK4WIS with VK7OTC portable. So at 1881
Hayden probably would have worked if you all had the generator not had a moment.
Anyway, yeah, moving on. That was the other bit of learning that we talked about a few weeks ago.
Who was OTC? That was
Because Hayden and I got together and we were actually OTC.
Yeah,
Oh, okay.
That was when they were on Mount Wellington. So
When Rex saved us with his generator.
yeah, brilliant save, excellent save, excellent save. The other thing here was active stations per state. We have the highest percentage of active stations per state. So the number of stations were 37. The submitted logs, though, was still only 20.
Over 50%.
Over fit. So
No, not quite.
yeah. So it wasn't bad, but anyway, we still had 37 people actually participate, but only 20 put in logs. So we'll just have to deal with that next time, and I think that was it. So there.
Arm tactics. The right at people's door. You put your log in. I'm going to stand there while you put your log in.
Yes, stand over you while you put your log in. So anyway, that's the Summer VHF, and I have to say, very well run contest, especially given that it's a distance-related contest, and which is usually an absolute nightmare to do the calculations with.
I think the grid square makes it
Just so much easier.
makes the maths a lot easier.
So yeah. Anyway.
Oh, we had fun. It was good.
Now, the other thing I wanted to just hint at with Richard here. Richard's been playing, one of the ones playing with a slightly increased power on 1296. So
In both directions, in fact.
in both directions, and you were able to be received and receive.
A bit of a milestone on Sunday. I was able to actually hear Tony.
VK7TU.
Tony has been very elusive. In the early days when we first started the 23cm net, there was with the standard VK7MO Xiegu, which was 19 elements, whatever. There was no sign of him at all.
Okay.
So we doubled the length of the antenna, and we still didn't really hear a lot of him. So we doubled the length of the antenna again, which was probably bordering on a bit silly, but
Nearly not quite fitting in Rex's garage.
so that was able to that little bit of extra gain made it to the point where you could actually tell that there was someone there.
Okay.
So we thought, well, okay, I did have a reasonably long run of feed line, like 20 metres of LDF 450.
LDF 450 though.
So, well, yeah, but you know, it's got tails and joins and bits and pieces. So when I bought the amplifier, I also bought a preamp.
Okay.
So I put the preamp in line, and sort of in the process there, also put the amplifier in line. And with the preamplifier last Sunday, with a bit of tweaking of the antenna, Tony was actually full quieting,
Wacko.
which was pretty impressive.
Very.
He obviously wasn't quite aware, first up, that I'd had a little bit more power travelling to the antenna.
Yep.
Because he made the comments to Rex that, oh, geez, ZBX has come up quite a distance. Tell him wherever he's pointing his antenna, leave
Whatever
it
he's
there.
doing, keep doing it.
So look, and most of the other stations around Hobart reported a significant increase.
Yeah. Okay.
So
You're
but
now
it was-
running limit power.
Yeah.
Cool.
Right on the edge.
Cool.
And allowing for a bit of feed line loss, but it's the preamp which is really sort of making the difference.
And in fact, that's an excellent segue.
Excellent.
Keep going.
How was your preamp going? Well,
that is, and you'll notice, I suddenly realised that I did get
because yours is going to go on the case, so you want the.
I did get the TNC connectors, and then I went, why am I putting TNC connectors on here when I can actually put SMA connectors on here?
Going in a box.
So, sorry if we.
As long as your mini kid's preamp is actually a preamp and not like the one I originally built for 2 metres, which was in fact a 2 metre attenuator.
Well, it's certainly all the checks that you have to do to get it, make sure it's actually supposedly working properly, and all of that sort of stuff, appear to be. It appears to be working okay.
It's nice.
So, the interesting thing with this preamp is it actually is the circuit is so that it can be in a box up at the antenna. So it actually has two RF relays, bypass relays for and a RF sense circuit that if it senses anything in the way of RF coming back up the coax, it switches over these relays, and if you flip over on the other side, you magically find that there's a little bit of bypass coax. So it goes straight through. And you can also, there is a power connector here, obviously, if you want to run it separately on 12 volts, and there's a little modification here because running it on 12 volts apparently got a few things a little bit hot. The 7805 a little bit hot, so there's a bit of a modification you do. But you can also run it with a bias T arrangement up the coax. So that's the mini kit's 23cm preamp.
This has got a gain control there too, so you can maybe turn the gain down, whereas yours is going to be inside the box and not at the masthead. Save the front end of your rig.
So what's the maximum gain?
Good question. That is it 14 or 20 or something like that? I think it's 14 or 20. I'll look that up. Sorry, Rex, I don't have that off the top of my head. But this is the last part of the scheme that I need. So watch this space.
Make a lot of difference. The preamp's just awesome.
So yeah, good segue.
I think they'll actually withstand the relays. I think they quote
50
if the
watt.
RF switch, they'll switch 50 watts.
50 watts. 50 watts SSB. 30 watts CW.
I think they say if you're going to have anything more than that, you can if you sequence it and actually switch it on and off, and rather rely on the RF switching. But
okay, and we have now figured out after our conversation last week how we can actually use the SG Labs transverter, the sequencer signal out of that to do the sequencing for the power on the PA.
Yep.
So I can definitively say there won't be any power on the coax relay when we switch it.
Yep.
So
that was the issue we had, like with that amplifier of mine, is because the Russian amplifier came with its own controller, and it controls the sequencing of the masthead preamp and the actual PA relay itself. You basically need to let it do all of the switching, so it switches the radio and does all the sequencing nicely.
Okay.
So what it means, of course, is that you have to have a separate switch, which in his videos he demonstrates the use of a foot switch.
Yeah. Okay.
So basically, when you hit the foot switch, it turns the power off to the preamp, disconnects it, blah 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 blah, and so on. But you've got to resist quite heavily the thing to want to pick up the microphone. So after talking to Rex, I come up with a little plan, which is a bit old school, with an 8-pin microphone plug and an 8-pin socket. You just basically push off, sort of pick off the PTT from the microphone, and have a switch.
Yeah.
So at least then you can use the microphone to.
That's all I do with the foot switch on my at home. So it's a bit of a jury-rig arrangement, but hey, it works a treat.
It's just if you sort of try and remember to do it in the heat of the moment, you'll pick it up and do the wrong thing, and then
and let the smoke out.
Yes, or the nice good ears and the preamp will go quiet.
So anyway, we're getting there. So Rex, this is sort of I suppose this is generation 2, because we've got to the point where we've got nearly 20 odd stations that are capable.
I would think so. Yes.
Of 23 centimeters in VK7, in southern VK7. And northern VK7 as well.
We've got a new one, of course. Andrew's just got a 9700.
Well and truly. So what we're doing is it's sort of the next generation in that we're getting preamps in place, we're getting power amplifiers in place.
Yeah. We've been doing it for 3 years, and over that time I've been very pleased to see how everybody's improved their systems.
Well and truly.
So it's...
And done some experimentation on the way through to improve their system.
That's right.
That's what amateur radio is all about.
That's right.
And keeping the fiberglass people and the aluminium people in aluminium boiling wire people in business as well.
Oh yeah. Okay. Yes. Well, and getting people actually building things.
Sure, half the welding shops now people turn up. What's the 3.25mm wire? Building an antenna, are we?
Rod.
Yeah.
They're the TIG wire.
Well, and I'm sure Capra will go, oh, here he comes again. Very good. Fantastic. Thank you very much, guys.
No worries.
Hope
to hear you next Sunday.
Yeah, okay. Oh, no, actually, no, I won't be on next Sunday. Sorry, got to go to a memorial service. Sorry.
That's okay.
Yeah. Very good. Thank you very much.
Thank you very much.
So, what we might do here... let's go this way. Okay. Just to finish off tonight, how are we going for time? Oh, we're 8:48. No, we might leave this until next week. I just wanted to mention also, just to finish off, Tecsun Radio Australia, which I came across their website the other day, which I'll post on the in the description of tonight. Tecsun have just announced that they are Xiegu, which is the Chinese amateur transceiver, the G90 HF transceiver. It covers 0.5 to 30 megs, so 10 meters through to 160 meters. with 20 watts of RF output in a very nice heavy duty sort of case. It is a software defined radio. I don't know what sort it is, and it's retailing for about $740. So it's not bad for a HF sort of QRP-ish type transceiver. I don't know its specs, but Tecsun Radio Australia are now importing them and selling them, and that's $740 Australian. And there'd be a little bit of shipping that would increase that, but they're now selling the Chinese Xiegu G90 portable amateur radio transceivers, along with their Tecsun, their range of Tecsun radios. Now, one of the things about the Tecsun radios is a couple of the little models that they use actually give you absolute readings on their receivers. So very handy for when you're doing. There's a couple of 160 metre experimenters who are actually using those to do field strength testing of their antennas. So really handy. But anyway, we'll finish off on that. It is 10 to 9, so well and truly. Our videos for tonight, a couple of ham radio DX videos, recent ones from Hayden VK7HH. The Baofeng, the UV5R is the cheapest ham radio in 2020, and then also configuring the ICOM IC9700 for WSJT digital modes. Then there was a scary video which I came across, which is a 9.0 Richter earthquake in Japan, which is videoed at a airport, and also the tsunami that follows, that inundates the airport. Just a really scary video of what a 9.0 Richter, which is a severe earthquake, an absolutely severe earthquake on the Richter scale, what it actually looks like. Then we'll probably get into this, but we won't finish it. The ICOM IC705, the ICOM US got together with the Amateur Logic guys and the ICOM dealer, who was going to the Orlando Ham Show, and did a review of the prototype of the 705. And now this is an actual review. They are using this particular radio. He's going through the functions of the radio, etc. So I think that's probably where we're going to get to tonight, or we're going to run out of time. So I'll keep those next two for next week. Anyway, this is VK7OTC, the club station of the Radio and Electronics Association of Southern Tasmania, with our DATV Experimenters Night, and we'll zoom across to our videos. So 73, have a great week, and we'll catch you next week with our next instalment. 73, and have a great week.